Imagine a place that was once a giant, shimmering lake, filled with water under a sky that looked very different from the one we see today. This isn't a scene from an ancient Earth history book, but a real location on Mars. It's called Jezero Crater, a vast 45-kilometer basin just north of the equator. Scientists, like detectives of the cosmos, believe billions of years ago it was a bustling delta, where a river flowed into a deep lake. It had the right ingredients for life: water, minerals, energy. That makes Jezero one of the most exciting places to explore in our solar system. Our story begins with a remarkable explorer, Perseverance, a robotic rover sent by NASA. Packed with advanced scientific instruments, Perseverance landed in this dried lakebed in February 2021, on a mission to search for signs of ancient life. Think about that. We sent a robot over 200 million kilometers through space to look for evidence we are not, and perhaps never have been, completely alone. Its job: carefully examine the rocks and the soil for clues left billions of years ago. The idea of this mission makes your brain do a happy dance. Now, you might be thinking, life on Mars? That sounds like science fiction. But what if I told you that Earth and Mars might have been cosmic roommates billions of years ago, sharing more than just a neighborhood in the solar system? Some scientists, like the brilliant astrobiologist Chris McKay at NASA, believe that our two planets have been trading materials for eons. It's a concept called panspermia. Imagine a massive asteroid slamming into a young Earth, or a comet slamming into a young Earth. That young Earth was teeming with simple microbial life. The impact would have blasted chunks of rock right off our planet. It would have blasted chunks of dirt. It might even have blasted some hardy microbes. Those ejected pieces would then wander through the solar system like cosmic tumbleweeds. A tiny fraction could have found its way to Mars. Ancient Mars had a much thicker atmosphere. Ancient Mars had liquid water on its surface. If any microscopic travelers survived the journey, the intense radiation of space, or the fiery entry into the Martian atmosphere, they might have found a welcoming new home. In that case, life on Mars wouldn't be truly alien, but our distant, long-lost cousin. The spark of life from Earth may have taken root on a second world. This exchange could have worked the other way too. What if life started on Mars first? So, if life did exist on Mars, what would it look like? You can forget about the bug-eyed monsters from old movies. Given Mars's harsh environment today, thin atmosphere, freezing temperatures, intense radiation from the sun, any life that survived would have to be incredibly tough. We're talking about the ultimate survivalists of the biological world. We don't have to look far to find examples. Right here on Earth, extremophiles. Lovers of extreme conditions. They thrive in places we would consider completely uninhabitable. Meet one of my favorite microscopic superstars, the tardigrade, also called the water bear. Tiny, 8-legged, indestructible. Tardigrades can survive being frozen to near absolute zero. They can be boiled in hot springs. They can be crushed by immense pressure. They've even survived exposure to the vacuum and radiation of outer space. They do this by entering cryptobiosis, drying out and shutting down metabolism almost completely. If life ever existed on Mars, it might have evolved similar strategies. To survive the planet's change from a wet world to the cold, dry desert it is today. It's not just tardigrades. Bacteria can be just as tough. Some bacteria form protective spores when things get rough. Those spores let them hibernate for millions of years. Spores can withstand huge doses of radiation. They survive long periods of drought, then reanimate when conditions improve. But just a few centimeters down, inside rock or under soil, microbes could be protected. They might be patiently waiting as spores, or actively living off scant water. To find these tiny, tough signs of life, the Perseverance rover is equipped with a suite of amazing scientific tools that make it a rolling geological and astrobiological laboratory. It's not just poking around randomly, it's performing sophisticated experiments on the Martian surface, all while being controlled by scientists hundreds of millions of kilometers away. One of its most impressive tools is an instrument on its mast called the SuperCam. Think of it as the rover's science eyes. It uses a powerful laser to analyze rocks and soil from a distance, which is incredibly useful for surveying the landscape and deciding where to explore next. The instrument can fire a concentrated laser beam at a rock target up to 7 meters away. The laser is so powerful that it instantly heats a tiny spot on the rock to about 10,000 degrees Celsius, vaporizing it into a glowing plasma. The supercam then analyzes the light from that plasma using a spectrometer. Every chemical element gives off a unique signature of light when it's heated, like a chemical fingerprint. By reading these signatures, scientists can instantly tell what the rock is made of without ever having to touch it. It's a brilliant way to quickly identify promising targets. If the supercam detects something interesting, like organic molecules or high concentrations of elements associated with life, such as nitrogen or phosphorus, the rover knows it's time for a closer look. One of these is called Sherlock, which uses its own laser to scan the rock for organic materials and minerals that form in watery environments. Collecting samples is only the first half of this extraordinary mission. While the instruments on Perseverance are amazing, the most powerful scientific laboratories are still right here on Earth. To truly confirm the presence of ancient life, we need to get those Martian rocks and soil samples back into the hands of scientists who can analyze them with instruments far too large and complex to send to Mars. This is why Perseverance is also the first leg of an incredibly ambitious interplanetary relay race, the Mars Sample Return Campaign, a joint effort between NASA and the European Space Agency. Here's the game plan: collection by rover, launch from Mars, return to Earth. As Perseverance explores Jezero Crater, it is drilling out pencil-sized cores of the most promising rocks, sealing them in ultra-clean, airtight titanium tubes. The rover then carries these tubes with it, or strategically drops them at a designated location on the Martian surface, creating a sample depot. This cache of samples will act as a scientific treasure chest, waiting for the next phase of the mission to begin. The rover has been carefully documenting the exact location of each tube, creating a map for a future mission to come and collect them. It's an act of scientific foresight, preparing for a future we are actively building. The next step in this cosmic delivery service involves 2 more missions. First, the sample retrieval lander will touch down near the sample depot. It will deploy a small fetch rover that will scurry across the surface, pick up the sealed tubes, bring them back to the lander. Once the samples are safely aboard, the lander will do something unprecedented. It will launch a small rocket, the Mars Ascent Vehicle. This rocket will carry the precious container of samples into orbit around Mars. If this grand, multi-mission effort is successful and we find definitive proof of life in those Martian samples, it would be a watershed moment for all of humanity. This wouldn't just be another interesting scientific fact, it would fundamentally reshape our understanding of our place in the universe. It would be as groundbreaking as 1543, when Copernicus proposed Earth wasn't the center of everything. That shift showed we weren't the physical center of the cosmos. Finding life on Mars would be a similar, profound shift. Discovering life beyond Earth would start a scientific and philosophical revolution. It would be on par with discovering DNA, the code connecting all life. Finding microbial life on Mars would show biology isn't a one-time miracle unique to Earth. It would suggest life is a common outcome of planetary processes. The universe would suddenly feel much less empty. We would finally know we are not alone. Think of the questions this opens up. Is Martian life based on DNA like ours, a common ancestor? Or does it use completely different chemistry, a second genesis? But what if, after all this searching, we don't find any evidence of life on Mars? What if the samples come back to Earth, and after years of careful study in our best labs, we conclude that Jezero Crater was sterile? Would the mission be considered a failure? Absolutely not. In science, a negative result can be just as informative and important as a positive one. Not finding life on a planet that we believe had all the right ingredients, liquid water, organic molecules, and energy source, would be a profound discovery in its own right. It would raise a whole new set of fascinating questions. If Mars is truly lifeless, it could suggest that the origin of life is a much harder, more complex, and rarer event than we thought. It might mean that having the right ingredients isn't enough. Perhaps a very specific and unlikely spark is needed to get biology started. This would make life on Earth seem even more precious and special. It would force us to reconsider the rare Earth hypothesis, the idea that the specific conditions that allowed life to flourish here are exceptionally uncommon in the universe. It would make us appreciate the immense chain of fortunate events that led to our own existence. Furthermore, even if we don't find ancient microbes, the samples brought back from Mars will be a scientific treasure trove. For the first time, geologists, chemists, planetary scientists would be able to study pristine Martian rocks in incredible detail. They could precisely date the formation of the bedrock in Jezero crater, unravel the planet's climate history, and understand how Mars transformed from a warm, wet world into the frozen desert we see today.